Sure.
Hello, welcome to this week's Retrieval Market Demo Day. Today's date is Wednesday, the 11th of May, 2022. On the schedule today, we have New Web Group talking about Titan Ultra Networks, the first milestone, and Leeway Hertz speaking about the retrieval performance dashboard. So we'll hand over to Edmund from New Web Group to start us off.
Hello everyone, this is New Web Group. Today I'm going to talk about the Titan Ultra Networks as shared CDN for Web3. In this meeting, we have Senior Software Engineering Manager Lin and Project Manager Yuan, and me, Edmund, as a presenter for this. If you have any questions, you can ask Lin, so I'll do the translation for you, and also Yuan. Basically, let's get started. Today's agenda, we're gonna talk two things. The first what we're gonna talk about is what is Titan Ultra Networks, and also we're gonna talk about the interpretation of Titan Ultra Networks function model. So what is the Titan Ultra Networks? Titan Ultra Networks is a high-speed CDN service for Web3. Based on IPFS protocols, which pushes the content close to user through certain rules, so that user can get the content they need nearby, in order to resolve network congestion problems, reduce network bandwidth costs, improve business response speed, improve user experience, and ensure business data security. And how do we do it? We can make full use of the shared network resources. Nodes can cover PC, clouds, mobile devices, etc., to make full use of edge nodes, storage capacity, and idle bandwidth to provide a better user experience. The role of Titan Ultra Networks. There are multiple parties involved in entire Ultra Titan network systems, each with different needs. In version 1.0, we divide them into user, edge nodes, candidates, validator, schedulers, reputation system, dataset, and retrieval portals. The specific division of labor for each role will be explained in details on the Titan websites and national documentations. How to join the Titan network? The service provider of edge shared nodes only need to install the Titan Ultra Networks, share resource clients, connect to the network, generate a Filecoin wallet, and becoming a family edge IPFS lightweight nodes, participate in contributing resources and get few rewards, idle bandwidth, storage resources through the Titan Ultra Networks, transform into the Titan Ultra and transform into a shared pool of resources, which are cached in advance by the Intelligent Scheduling Center to achieve acceleration through resource usage frequency. Condition for becoming an edge node. The upload bandwidth. The initial bandwidth threshold is set at 10 megabytes per second. Users are allowed to freely choose the amount of resources they wanted to contribute at the beginning of the installation process. The scheduler will not use more resources than the value filled in by the user for the service provider nodes. The inspection cycle. The inspection is carried out in every 5 minutes. It will check every 12 times in every hour, and the revenue will be generated after 900 times of inspection. The node is examined for stability, resource quality, security, etc., to determine whether it is a malicious node or not. If the quality of service is consistent with the commitment, the node starts to generate revenue after 900 heights according to the volume of service. The requirement to become a candidate or verifier. The pledge coins. Candidates need to pledge the corresponding Filecoins. Election cycle. According to our setting, each candidate is qualified to be a verifier and each election cycle, that is 7 days, a certain number of verifiers will be randomly selected from the candidates to verify the validity of the storage and bandwidth of the node across the network. How do users get file accelerations? In Titan networks, users just need to enter the CID, just like we use Google search, and then get the file to download. Based on the frequency of the content usage, the scheduler pushes the content blocks from verified nodes and candidate nodes to the appropriate edge nodes. Based on the source IP of the user request and the IPFS block CIDs, the user is provided with the optimum delivery path. Accelerate principles, in other words, commanding scheduling. How does the scheduler know what blocks are stored in each candidate's nodes, verifier nodes, and edge node? The scheduler directs the candidate nodes or verifier nodes to pull blocks on car files from IPFS Filecoin. If the blocks are pulled, the CID are returned directly to the scheduler. If it is pulled car file, the candidate nodes or verifier nodes need to return the CID of all the blocks inside the car file after pulling a whole car file. Finally, based on the frequency of the content usage, the source IP of the user's request and the IPFS block CIDs, the scheduler directs the edge nodes to the candidate nodes verifier nodes to pull the blocks for cache. This makes the transmission better. How does the verifier node know what blocks are stored in the candidate node and edge node? Candidate node is a kind of node that in Titan networks, according to our setting, each candidate is qualified to be a verifier and elected cycle tentatively 7 days. A certain number of verifiers will be randomly selected from the candidates to verify the validity of the storage and bandwidth of the node in the whole network. The scheduler directs the verifier nodes to the authentic nodes of the whole network and verify the results, and uploads key information, that is the storage capacity, bandwidth, and online hours, and for each height. Thirdly, later, when the FVM, the Filecoin virtual machine, is online, we will develop the corresponding contract support. After each election cycle, the scheduler will reward or punish the nodes based on the verification results. How and what files are accelerated? Our target for acceleration is IPFS blocks, so there's no restriction on the file size or file type, and the IPFS blocks can be accelerated for all file formats and file sizes. When a file is uploaded to the IPFS network, IPFS cuts the file and the number of blocks cut for large file is high, while the number of blocks cut for small file is low. So whether this is car file, video data, etc., all can be accelerated. What types of files can be accelerated? How large the file transfer can be accelerated? Okay, let's take a car file for example. If a car file is pulled, then the candidate nodes or verifier nodes will be split the car file into several blocks after pulling the whole car file, and transfer the blocks to several edge nodes as are closer to the user. Compared with the direct acceleration of the car file, the effect of accelerated blocks is much better, and it requires less hardware resources, which is very competitive in terms of resource cost and acceleration effect. Blocks transmitted by the Titan networks are the combined into a car file or data needed by user through the Titan retrieval entrance, provide user with a stable, high-quality, downloadable accelerations. Does it support file storage? Does the Titan network's PCDN support the storage data? The Titan network does not support user to store data freely in the early stage. However, but the candidates and the verifier nodes of the proposal are essentially IPFS nodes, so they can be supported in the later stage. The acceleration effect can be obtained by telling the Titan networks the CIDs and the target areas. In the future, you can upload files to Titan networks, choose your acceleration resources freely, and pay according to the usage. If you have any questions, please not hesitate to ask me, and maybe I can translate to you with to Lin, or maybe you can ask Yuan for any further questions. Thank you.
I can start. Okay, thanks everyone for joining this call and giving us this opportunity to present. I am Deepak. Let me share my screen. And let me know if you can see my screen, Patrick.
Yes, can see.
Perfect. Okay. So I'm Deepak. I'm the CTO with Leeway Hertz, and we've been working with protocol labs building on Filecoin for almost 3 months now. And we've been working closely on basically capturing the network performance. So we are working on retrieval performance dashboard. So in this specific product, what we are doing is, as you all know, Filecoin has been like successfully able to measure and analyze the storage performance of various files. Although the retrieval performance is something that has not yet been monitored or has not been measured so far. So as part of this project, this is what we are planning to do. We are basically comparing the file retrieval from various storage providers. The value in this is to basically compare all these different storage providers and find out the performance based on various matrices. So the overall networks that we are planning to or storage providers that we are planning to cover in this project are Cloudflare, Estuary, Meson, Web3 storage, IPFS, Mail, and as we move forward, we'll see if there are new storage providers, we'll include them also. So based on different matrices, what we are trying to do is we are trying to get the performance of the retrieval of a specific file based on the location. So the matrices are TTFB, which is time to first byte. So let's say if I, as a user, tries to fetch the file from one of the networks, let's say Meson or Mail, how much time it takes us to basically fetch the first byte, and then what is the overall time it takes us to download that file using the CID. So TTLB, which is time to last byte. We are also working, like the extension to this whole project is to basically provide the reputation score also to these storage providers and retrieval providers. So that's the overall project that we are working towards. Now, this is the high-level designs. I'll walk you through the whole design, what it contains, and what all different components of this project are. So let me just jump to the real performance dashboard. So this is the working prototype of the overall project. So over here, if you see, what we have is we have these different storage providers that we are trying to compare in this first version. So these are the storage providers. Then what we have done is we have launched like multiple bots in different locations. So these are the different locations where all these bots are available. Now, corresponding to each storage provider, what we have done is we have stored one file, and corresponding to that file, we have the CID available, which is the content identifier. And we are trying to fetch that file using different bots that are running in all these different locations. Over here, what we are trying to show is, let's say if we have nft.storage as one of the storage provider, and we are trying to see the performance in from the location North Virginia. This is the file, and this is the time when we last fetched this performance. So you can basically find this performance for last 7 days or 30 days. Then corresponding to this, we are showing what is the best speed time, what is the average speed time, and the worst speed time for this specific file, for this specific location, for this specific storage provider. Now, on the right hand side, you can also see all these different nodes that are running, different bots that are running from different locations. And based on these color coding, these legends, we are basically showing what is the performance of that specific location to fetch that specific file. Now over here, we are showing like all these like this is like a real-time dashboard that we are showing here. So for Bahrain, for estuary, what is the current TTFB for a given CID. Now, all these files that we have stored on these different networks, they are pretty much of the same size. So I'll explain a little bit in more detail when I explain the source code structure as well. So this is like the current the retrieval time, what it takes for any CID to fetch. If you see, there are different color codes. So under 200 milliseconds, this is the color code. Then we have divided pretty much it into like 5 different legends: excellent, good, average, bad, and poor. You can basically go ahead, change the TTLB performance here. You can see the difference. So it's live. You can change the location also. So let's say if we change it from North Virginia, let's go to Southeast Asia. So this is the time it is taking for that specific content to fetch. You can basically try to see different storage providers, what are their performances. So this is the performance based on the file which is available, the location. So this is on a very high level how the dashboard looks like. So now we can basically move towards the architecture of this application also. Now, before I move to that, there are a few new dashboards that we are working towards. So let me just try to show it here. So so this is the historical graph that we are trying to show with respect to these different storage providers here, with respect to a specific location. So how these networks are performing over a period of time. And what we are also showing is like based on a certain event, if certain networks performance goes down or up. So we are also trying to capture these different events that has happened. Let's say there is a new version of the storage provider, any upgrades to their network or anything, and what is the performance after that specific event. That's what we are trying to show here. Or you can basically change the time period also. And over here, you'll see the dates and the performance in terms of milliseconds. So this is something that we are still working towards. Now, if I just quickly move to the high level architecture for this application. So what we have here is we've created a config file in the system which basically consists of uh, the information around the content URL, the CID, and the base URL that we're using for that specific network, and what is the destination from where we are trying to fetch that specific file. So this is the config file. It it is available with the scheduler service. So in the scheduler service, it picks up this config file and keep pushing the events, file retrieve events in the AMQP over here, and it's happening like every 30 seconds, so that we can in real time we can monitor the performance of these storage providers. uh, so these are various bots that are running in different regions of AWS as of now. uh, I'll explain a little bit more around different infrastructure services that we are planning to use. But as of now, we are using AWS, and these are different bots which are running in like almost 22 regions. So these bots, they receive the event and they have all the information in order to fetch the file. So they fetch the file, and they have the logic built in, wherein they create another file retrieved event to this next queue. In this, we are measuring the TTLB for that specific file content. TTLB, the time period, the location at what time, from which bot location we have retrieved that file, and we are storing it in the database. Uh, and then using the APIs, we are trying to show that on the front end. This is like on a very high level how the overall architecture looks like. Now, if I just quickly jump to the source code also, these are different microservices that are running in the system. As I explained earlier, we have a scheduler microservice. So in this scheduler microservice, we have the config file defined under modules, jobs. So this is the config.json, wherein we have defined these content URLs, network destination, file size, and the CID for that file. So it basically reads this config and pushes the content to the AMQP, which is running again on AWS as of now. This is the content retrieval bot. So these are the bots which are running in different AWS locations. Now, what it does is, as I explained, this is what it does. Fetches the file using the config and then capture TTFB, TTLB for a specific time period, and then accordingly construct a event and push it to the event to the AMQP again. Again, there are a couple of microservices that we have created for storing and for the API purpose. So this is on a very high level, the source code for this project. Now, if I talk about like what's upcoming, what are the new things that we are planning to work towards, and then maybe after this we can take up some questions. So as of now, as I mentioned, we are using AWS as for launching these bots. Now, in order to get a real-time scenario from a end user perspective, like there could be some network issues, there could be some latency from an end user perspective. So we are trying to utilize these infrastructure services that are available in different regions, and so that we can have much better matrices. Some of the networks that the storage networks that we are planning to bring in into the system, like Saturn is one of them. Then IPFS Cloudflare is there, Titan and Mile. So this is from a matrices perspective. one more matrix that we would like to bring in into this system is, so it's like a end-to-end use case wherein a bot receives a file. That bot basically store the file using one of these networks, one of these storage providers. We store the file and then we try to retrieve the file also, so that from storing and then up to the retrieval, we can calculate the overall time taken for that entire process. And in that case, what we are trying to achieve is, one is the storage time, another one is the retrieval time, and then there is the cloud distribution time as well. That is also one of the important aspects that we are trying to cover in this project. Beyond that, we have some thoughts around the creation of these reputation system using the reliability, scalability, the performance of these storage provider networks, and create some sort of score around that. So that's on a very high level. I know we can go a little bit in more detail, but we can always take in questions after the second presentation. I think I'm done here, Patrick. Anything else I would like to add? I can.
Great, yeah, thank you very much. I'm just going to add one clarification, which is, where at the beginning you were talking about storage providers. We use the word storage provider to talk about the Filecoin node to actually storing the file and sending proofs to the chain. So in this case, it's retrieval providers or retrieval networks that we're measuring the performance of. But yeah, all looks great. So thank you very much. Has anyone else